Warm greetings from TNV Academy. Today in this session, we are going to discuss about failure mode and effect analysis. Let me briskly tell you about the key learnings of this session. At the end of this session, you will be able to understand what is FMEA, when to use FMEA, FMEA procedure, benefits of FMEA, and the last one is types of FMEA. So let's start our discussion and talk about what is FMEA. Failure modes and effects analysis FMEA is a step-by-step approach for identifying all possible failures in a design, a manufacturing or assembly process, or a product or service. It is a common process analysis tool. Failure modes means the ways or modes in which something might fail. Failures are any errors or defects, especially ones that affect the customer and can be potential or actual. Effects analysis refers to studying the consequences of those failures. Failures are prioritized according to how serious their consequences are, how frequently they occur, and how easily they can be detected. The purpose of the FMEA is to take actions to eliminate or reduce failures, starting with the highest priority ones. Failure modes and effects analysis also documents current knowledge and actions about the risk of failures for use in continuous improvement. FMEA is used during design to prevent failures. Later, it's used for control before the during ongoing operation of the process. Ideally, FMEA begins during the earliest conceptual stages of design and continues throughout the life of the product or service. Failure modes and effects analysis FMEA is a systematic, proactive method for evaluating a process to identify where and how it might fail and to assess the relative impact of different failures in order to identify the parts of the process that are the most need of change. FMEA includes reviewing of the following steps in the process. Failure modes. What could go wrong? Failure causes. Why would the failure happen? Failure effect. What would be the consequences of each failure? Teams use FMEA to evaluate processes for possible failures and to prevent them by correcting the processes proactively rather than reacting to adverse events after failures have occurred. This emphasis on preventing may reduce risk of harm to both patients and staff. FMEA is particularly useful in evaluating a new process prior to implementation and in assessing the impact of a proposed change to an existing process. Let us now discuss about when to use FMEA. FMEA should be used when a process, product or service is being designed or redesigned. After quality function deployment QFD, which an existing process, product or service is being applied in a new way. Before developing control plans for a new or modified process. When improvement goals are planned for an existing process, product or service. When analysis failures of an existing process, product or service. Periodically, throughout the life of the process, product or service. Let us now discuss the FMEA procedure. The FMEA procedure involves the following steps. The first one is assemble a cross-functional team of people with diverse knowledge about the process, product or service. Functions often included are design, manufacturing, quality, testing, reliability, maintenance, purchasing and suppliers, sales, marketing and customers, and customer service. The second one is identify the scope of the FMEA. Is it for concept, system, design, process or service? What are the boundaries? How detailed should we be? Use flowchart to identify the scope and to make sure every team member understands it in detail. The third one is fill in the identifying information at the top of your FMEA form. The remaining steps ask for information that will go into the columns of the form. The fourth one is identify the functions of your scope. Ask, what is the purpose of the system, design, process or service? What do occur customers accept it to do? Name it with a verb followed by a noun. Usually, one will break the scope into separate subsystems, items, parts, assemblies or process steps and identify the function of each. The fifth one is for each function. Identify all the ways failure could happen. These are potential failures modes. If necessary, go back and rewrite the function with more detail to be sure the failure modes show a loss of that function. The sixth one is for each failure mode. Identify all the consequences on the system, related systems, process, related processes, product, service, customer or regulations. These are potential effects of failure. Ask, what does the customer experience because of this failure? What happens when this failure occurs? The seventh one is determine how serious each effect is. This is the severity rating or as severity is usually related on a scale from 1 to 10, where 1 is significant and 10 is catastrophic. If a failure mode has more than one effect, write on the FMEA table only the highest severity rating for that failure mode. The eighth one is each for failure mode. Determine all the potential root causes. Use tools classified as well as the best knowledge and experience of the team. List all possible causes for each failure mode on the FMEA form. The ninth one is for each cause. Determine the occurrence rating or O. This rating estimates the probability of failure occurring for that reason during the lifetime of your scope. Occurrence is usually rated on a scale from 1 to 10, where 1 is extremely unlikely and 10 is inevitable. On the FMEA table, list the occurrence rating for each cause. The 10th one is for each cause identify current process controls. These are tests, procedures or mechanisms that you now have in place to keep failures from reaching the customer. These controls might prevent the cause from happening, reduce the likelihood that it will happen or detect failure after the cause has already happened but before the customer is affected. The 11th one is for each control, determine the detection rating or D. This rating estimates how well the controls can detect either the cause or its failure mode after they have happened but before the customer is affected. Detection is usually rated on a scale from 1 to 10, where 1 means the control is absolutely certain to detect the problem and 10 means the control is certain not to detect the problem or no control exists. On the FMEA table, list the detection rating for each cause. The 12th one is optional for most industries. Ask, in this failure mode associated with the critical characteristics? If so, a column labeled classification receives Y or N to show whether special controls are needed. Usually, critical characteristics have a severity of 9 or 10 and occurrence and detection rating above 3. The 13th one is calculate the risk priority number or RPN, which equals S into O into D. Also calculate criticality by multiplying severity by occurrence S into O. These numbers provide guidance for ranking potential failures in the order they should be addressed. The 14th one is identify recommended actions. These actions may be designed or process changes to lower severity or occurrence. They may be additional controls to improve detection. Also note who is responsible for the actions and target completion dates. The 15th one is as actions are completed. Note results and the date on the FMEA form. Also note new SO or D, ratings and new RPNs. Let us now talk about the benefits of FMEA. Major benefits derived from a properly implemented FMEA efforts are as follows. The first one is it provides a documented method for selecting a design with a high probability of successful operation and safety. The second one is a documented uniform method of assessing potential failures mechanism, failures modes and their impact on system operation, resulting in a list of failure modes ranked according to the seriousness of their system and impact and likelihood of occurrence. The third one is early identification of single failure points, SFPS, and system interface problems which may be critical to mission success and safety. They also provide a method of verifying that switching between redundant elements is not jeopardized by postulated single failures. The fourth one is an effective method for evaluating the effects of proposed changes to the design and or operational procedures on mission success and safety. The fifth one is a basic for in-flight troubleshooting procedures and for locating performance, monitoring and fault detection devices. The sixth one is criteria for early planning of tests. And finally, let us now discuss the types of FMEA. The various types of FMEA are functional. Before design, solutions are provided or only on high level. Functions can be evaluated on potential functional failure effects. General mitigations designed to requirements can be proposed to limit consequence of functional failures or limit the probability of occurrence in this early development. It is based on a functional breakdown of a system. This type may also be used for software evaluation. Concept design and hardware. Analysis of system or subsystems in the early design concept stages to analyze the failure mechanism and lower level functional failures, especially to different concept solutions in more detail. It may be used in trade-off studies. Detailed design and hardware. Analysis of products prior to production. These are the most detailed in MIL 1629 called piece part of hardware FMEA. FMEA and used to identify any possible hardware for other. Failure mode up to the lowest part level. It should be based on hardware breakdown. For example, the BOM bill of materials. Any failure affects severity, failure prevention mitigation, failure detection and diagnostics may be fully analyzed in this FMEA. Process. Analysis of manufacturing and assembly processes. Both quality and reliability may be affected from process faults. The input for this FMEA is amongst others a work process and task breakdown. So, we have now come to the conclusion of this session. If you have any questions regarding today's topic, then please put them in the comment section of the video and we will be really happy answering them. Till we meet next, it's best wishes from TNMA Academy. Thank you.